But we can't do that.
No. Doesn't work.
Oh, it doesn't work.
It's just set that thing. Okay, vectors. So this is one of our final bits. Once we've done this, there's a few kind of tidy up things. So, for example, I think some of you were indicating that the proportion stuff in the assignment was way out of your memory, and you would have learned that in year 9. So we might need to just recap some of that. So there'll be a few little bits we're going to do before the mock. I'm hoping we're going to get most things done before the mock, but we may have to still clear up a few after. Anyway, I'm rambling. Vectors. Vectors, have you heard of vectors? Oh, you would definitely have heard of vectors, because I talked about vectors too.
In circles. Oh, no, that's
Physics people know, but I've also talked about it in maths. When have I used the word vector? Specifically, I've talked about when we translated that, do you remember? Okay, so anyway, a vector has both magnitude, which means length, and direction, okay? They're written as letters, and so I might see a bold letter or an underlined letter, because obviously in an exam you can't bold something. Obviously you can in type, but if you can't normally, so often it has an underline. The underline is normally squiggled. I couldn't do a squiggle underline, okay? Oh, good, someone's okay. So, column vectors. So we've seen these when we translated shapes. So, for an example, you might see the underlined is equal to, and they've defined it. This top number tells you any kind of movement right or left, and the bottom number tells you up or down, okay? Right, if numbers are positive, it means they're going right. Okay, and positive would be up. So if positive, the numbers are right and up. So if I wanted to display this vector, I would choose a point. So I'm going to choose this point here. From that point, I need to go to the right 4, 1, 2, 3, 4, and down 3, 1, 2, 3. And I've ended up down here. I would show the vector B by drawing a line from my starting point to my finishing point, and I would put an arrow on it. If I didn't have the arrow, it wouldn't be complete, because as I've said, vectors have direction. So this line could have been drawn from this point to this point. So I have to show that I started at this one and I finished at that one. So that's the movement 4, -3. Everyone clear on that?
Should you always put an arrow on the line? Okay. Arrow.
Yes, Emma, you should always put the arrow. Ideally, it would be great if you pay attention as well.
I know, but I'm just focusing on drawing the line. That's why.
Deep breath. Okay, so vectors are equal if they have the same magnitude, same length, and the same direction. Okay, so if looking at this diagram here, these have the same length, but they do not have the same direction. Therefore, these vectors would not be equal to each other. Yes, do you agree with that? What else have I said here? Okay, they're not equal, or they're the same length, they act in opposite direction. All right, so let's identify this. Now, I apologise, the arrows are really tiny, and just the smart is the arrows. I couldn't make the arrows any bigger. Okay? So, check to see where it starts and finishes. So this one obviously starts here and finishes at this position. How would I describe this vector? It's going to be in a column. Remember to try and avoid doing the line between them. Which direction horizontally have I moved? 2 or -2? 2, nice. Good, I like that, Jodie. So 2, not -2. And which vertical movement have we made? -5 or 5? adrenaline rush.
3, 5.
Okay, Nathaniel's saying -5, someone else was shouting 5.
Oh no, I was saying
What's that? I'm just waiting for it, yeah?
Never mind.
Sure? Someone put you off from asking questions. It would be great if you didn't ask the question about something I've just finished saying.
Like the starting point? You start here, right?
Yeah, as I said, I should apologise. My arrows are really small and at the very end of the line. When you have them in an exam, it will be clear which direction.
Start at one end of the line.
Yeah, it does matter. So the end that doesn't
Have an
I don't know how to. How about this next one? Pardon? 4 and 0. This next one.
6 and 3.
6, 3. I'm not counting, so I'm trusting you lot. Okay, now we need to draw the vectors. Now, when you're drawing the vectors, I don't know if you recall, and when we were drawing gradients, remember when we did those? Try and think of a good place to start your point. So think about this, we need to move to the right and then down. So you're not going to put it way down, start way down here at the bottom, because you've got to go down even further. So we need to go right 5 and down 2. So if I'm going to start here, and I'm going to go right 5, 1, 2, 3, 4, 5, down 2, 1, 2, and I'm going to draw a line and put my arrow clearly in the middle. That's fine. In an exam, try and get as straight as you can. It's not. You're more going to be looking at they'll probably give you the vectors. You're not very often asked to draw them. And this is just making sure you understand the concept. So 4, 3, okay, this one we're going right and then up. So again, you're not going to start your point way up here. I'm going to start mine down here a little bit. So there's my 4, 3. And my -6, -1, I'm going left and then down. So I'm going to start over here on the right hand side. You in the wrong way, Jada?
Yeah, I'm gonna come on. But I understand what.
Do you see down there?
Yeah.
Yeah. Okay, is that okay? Straightforward? Yeah. Adding vectors. So adding vectors is literally you're going to have one vector. You're then going to at the finishing point of the first vector, you're then going to draw the second vector. Okay, so if you were asked to actually draw this, you would have A plus B. So that our movement that we're following along the line, so this would, the blue one would take us, vector A would take us from here to here, vector B would then take us from here to here. So this here, the A plus B, is called the resultant. Okay? Now, quite often we have things labelled with big letters on the vertexes, or the vertices, sorry. So if I was trying to describe to get from X to Y, I do not know what this actual movement is, but I do know that A goes in this direction. So whilst it seems weird to go out of the way, this is obviously the shortest route, I could make the move up this line and then along this line, and I still end up at the same place. Yes, so you're going around the houses, but you know that this is the vector A and this is the vector B, and if when we add those together, we get the same point. So X to Y would be following up here, along here, so both of them are in the positive direction, so it's A plus B. If we were going from Y to X, I'm going in the negative direction of B. and the negative direction of A, so it would be negative B minus A, or minus A minus B, it doesn't matter.
So when you say something's going in the positive direction, it means it is following the arrow?
Correct, yes. And that's why having the arrow on there is really important. Alright, so it would take a long time to draw out each vector if asked to add or subtract them. Okay, so if you're asked to find the resultant of things, you're literally just going to use, as I've said here, simple arithmetic with the column vectors. So if I've been told that vector P is equal to A plus B, I would literally look to see, right, vector A is 4, 1, and I'm adding on vector B, which is negative 3, 5. So if I've gone right 4 and then down 3, my resultant is going to be the sum of these two. So we're going to say, what's 4 plus negative 3? 1, yeah? And what's 1 plus 5? There, that's it. Okay, so if you were asked what's A plus B, you would literally just add the two vectors together. Magnitude. So we've talked about magnitude. Magnitude, I said, meant length of. Yes? Okay, so it's the size of it. Now, you'll know that each of these vectors are diagonal-ish lines. Okay, some of them, yes, they're horizontal, but most of them are diagonal lines. We can form ourselves a right-angled triangle for every single vector because we know that we've got a horizontal and a vertical movement. Yes? So, what do you think we do? If we're trying to find the length of this line, what rule might we be using? Pythagoras. Yes? Yes, the and. Oh, everyone's very excited to be at maths today. Oh, and Patrick says it here. So, we said vector P was 1, 6. 1, 6. So, that means that this measurement here would be 1. This measurement here would be 6, okay? Because I started here, I went across 1 and up 6. So if I was to try and find the magnitude of P, we'd show that by doing these lines here, the modulus lines, okay? So that's the scalar, that's the magnitude. And we would use Pythagoras' theorem. We know it's going to be the square root of 1 squared plus 6 squared. Now,
I'm sorry, can you rewrite that? What is it? It's brackets?
this, there's straight lines.
Oh, straight lines.
These are.
But it's not.
What's in the middle?
P.
What this is straight.
Okay, so P has been underlined. The trouble is when you underline P, it looks like a weird symbol.
That looks like a fall.
Yeah.
This is
I
P.
know you did.
Me too. Okay, me 7, but this is a P,
And then you got to
and then underline it.
Get you under.
Oh, no, underline it. Oh, wait, underneath. I don't care what you underline.
Oh.
No wonder those straight lines is what.
Meant to be squiggly?
Yes, it's meant to be squiggly. Remember I said that as well, Emma? I know you said it.
And what do those two lines on the other? Doesn't matter how squiggly it is.
No. The nice thing is I do get all of these questions on film. And so I can go back and say, really, this is what I have to deal with. Okay, so we're now happy with the sign. It says P. Yes, good? Good. Now, the nice thing about these Pythagoras things is that it's always going to be plus. Because our vector is always going to be our hypotenuse. All right? So you don't have to think, oh, do I have to add or subtract stuff? It's always going to be adding. Okay? So, 1 plus 36. Now, you can leave them as square roots. Okay, so you can leave it as root 37. That is the exact answer. And if they've asked for it to be rounded to any kind of amount, 3 sig fig, 1 decimal place, you'd obviously chuck that in your calculator and give them the value of it. Well, let's have a look. Let's have a guess roughly what it's going to be. This is root 37. So what number? It's going to be 6 point something. Awesome.
6.082762.
6 point, pen into 3 sig fig, please, Emma.
6.08.
Lesbians? Yep. She has nothing. Yeah.
I know.
Gosh.
It's 6.082. So you.
All right, scalars. And if this here was vector D, and this vector here was twice the length of it, we can describe this as 2D.
Not.
What? Okay,
It's crazy.
wicked, isn't it? Double the length,
Oh.
having 2 in front of it. It's just like crazy maths.
This
This one here is 3 times the size of this. But look, this one goes in this direction, this one goes in this direction. So we'd call this negative 3D. Check that out. Okay?
Are you astonished?
Alright, we're going to bit too far now. Okay. If vectors can be written as a scalar, okay, so if one is a multiple of the other, then it means they must be parallel to each other. Okay? Because we know if we moved across, so let's say a vector is 1, 3. If we moved across 1 and up 3, and from this position, if we moved across 1 and up 3 from this position, we know that those lines have to be parallel, yes? If we, from this position, or actually anyway, from this position we moved across 2 and up 6, we still know that they're going to be parallel. Oh, that was not a good diagram because it really doesn't look parallel. But because they're in the same movement and they can be simplified to be the same rise and run, they would be parallel lines. Yes, you all happy with that? So, R is equal to 3A plus 2B minus C. First of all, we're going to, that's the end full stop. Why have I got this random thing down here talking about the magnitude? Bless my cotton socks. Okay, that's the end of that sentence. Here sometimes vectors can have more than 2 things. Okay, so we've got 3 lots of vector A, 2 lots of vector B, minus vector C. Okay, so we need to first of all find out what that is. So we're going back up, way back yonder, to looking at vector A, B, and C. So what was vector A?
4, 1.
So we've got 3 lots of 4, 1, plus 2 lots of,
Minus 3, 5.
thank you, minus
Minus 1, minus 2.
Is everyone happy with that so far? What do we think we're going to do if we've got a big fat number in front of a vector? See, you don't even need me. So this vector would now be
12 over 3.
12, 3, yeah. This vector would be
Minus 5. No, minus 6.
Minus 6.
10.
and then we're taking away this one. I'm just going to leave it as negative 1, negative 2.
Wouldn't it be minus 1 times minus 1 so it's equal to 1?
Oh, we're going to get to that. So now we've dealt with our numbers in front. So now we're going to actually do the addition and subtraction. So we've got 12 plus negative 6. What's that? 12 plus negative 6 is 6. Take away negative 1. So that makes it 7. Ooh, no, 13. Now obviously you've got your calcs that help you, so if you're going to make a mistake, but if you are less confident with your integers, just use the calculator, okay? We've then got 3 plus 10. Take away negative 2.
15.
And we've been asked to find the magnitude of it. So we know that that's going to be the square root of 7 squared plus 15 squared. I always forget 115 squared, is that 225?
Yeah, it is. Absolutely. Yeah, it is. So that's
Hannah, you asking me?
yes. You probably mentioned it, but the 2 lines either side of the arm with
They just mean the length bit. Okay, they're called the modular signs. But, so they're just straight lines. So if you ever see the straight lines, that's what it's asking you to find the length of the line. Anyone happy with this? No? Anyone? Yeah, but wait, it's very well then.
16.6.
Yes, yes. Okay, Chris, yes?
16.6. Yeah, that's the pretty significant.
Oh, I thought you were telling me, you were just asking. Right, okay, let's do a little bit of work on this stuff first.
Oh, wait,